Let me continue. We are already discussing the matrices and inverse and its inverse. Okay, so uh, one property for the matrix and inverse is if you multiply the matrices with its inverse from the left or from the right, it will be resulting the identity matrix. Okay. And then you can also set up matrix equations in which the matrix on the left is your constants, and this is the variables, and this is the constant on the right side of the linear equations. And you can write all this into the a x, the variables, and then the b. So you can write that up, and you can do some algebra in this matrix equations. One thing to remember is if you multiply, like you multiply a, b, for example, you have a, you have b, a, b will be different from b, a. Okay, that's one property in matrix that's really important. And also you can write down, have ax equal b. You can write down and solve for the x, and you have the a inverse b. Okay, so this is also a property that I think important in matrix. Okay. Now the next case or the next set of problem will be about the determinant. So this will be determinant and the Crammers rule. I will start with the 2 by 2 matrix. I think I've mentioned last week that a determinant of 2 by 2 matrix, let's say matrix A, let's say it has A, B, C, D. So we can write determinant as that A equal, or you can write the A and then having absolute, and then write like this, having like an absolute value, it's determinant. And you can write AD minus BC. I think in linear algebra, you will see determinant very often. Yeah, very often. Um, Actually, determinant is a set of a scalar value. A scalar value of if you have set of matrices in which the matrix is from the linear equations. The determinant is a set of value, the scalar value that when you put the matrix into the determinant, it will get the output, the scalar value, and it will be defined as this AD minus BC. Okay, in this a 2 by 2 matrix. Okay. Now, if we maybe not 2 by 2, maybe 3 by 3 or 4 by 4, 5 by 5, what should be defined, okay, in terms of the calculation of the determinants? Okay. Let me write this one. So determinant of n by n matrix. Okay, to define this determinant, we need to define minors and cofactors. There's a lot of terms, but it's I think uh, if you see how we are deal with the calculation, it will be much easier. So let's see the A. Okay, so let A be n by n matrix. The minor, let's write the minor as M and then I, J of the element A, I, J is the determinant of the matrix obtained by deleting the I and J row. Oh, sorry, column. I've row and J column of A and cofactor of element is, we define this as and then M, J. Okay, so let me define it out. This, okay, so this will be the determinant. This will be the cofactor. Cofactor. This will be cycling between which one? The big M. Yeah. Yeah. We call also the minor. So the minor is actually the determinant in which we are deleting the I, some row and then some columns. Okay. Uh, I believe it will be more practical if I'm giving you an example. Okay? Let's say we have example A, 2, 3, -1, 0, -2, 2, 5, 4, 6. So M, if I say M12, okay, or let me draw what will be the A11, A12, A13, A21, A31, A22. This is the how we write the number of row and column. Okay, so top left is 1 1, 1 2, 1 3, 2 1, 3 1, and then the top bottom right is 3 3. Okay, so if I'm writing the M12, the meaning is we are focusing on 1 2 here, and the row and column we need to delete. Okay, and we are focusing on calculating this element and this element. Okay, so let me draw for you. Okay. So, or let me draw in the new set of matrix. Okay, so let me write this all number, and then this row 1 and column 2. Okay, and we can say that this is actually determinant. It's different. Okay. Okay. This is the matrix. Okay. This is determinant. Okay. I'm calculating the determinant. And now we are treat the 0, -2, 4, 6 as 2 by 2 matrix. Okay. So AD minus BC. Okay. Or let me write down all the process. So 0, 6, -4, -2. So it's 8. Okay. And then A12 is -1, and then I plus j is 1 plus 2. Okay, so it's 3, and then M12. So it will be -8. Okay. So the minor is only the value of how much the value of its determinant. And to get all value, the cofactor, we need to multiply with this -1 with power of the row plus the column that we want to observe. Okay. And actually, if you think like in the matrix, okay, if you imagine from A11 until A13 until A33, okay, until A13 here, we can imagine 1 is even, right? And it should be positive, right? -1, -1, it should be positive. So you write this positive, and then negative, positive, negative, positive, negative, right? I believe, I think in high school you see this, right? Your teacher, no? Really? Okay. Sometimes they draw like, they don't really explain how we get this, but they explain how we are calculating determinant and inverse. Like if you have 3 by 3 matrices, you will have the first is positive, second is negative, third will be positive. And if you start from here, it's negative, positive, negative. But usually, whenever you start from this column or from this row or this row, uh, the result is the same. I will explain later about that. Okay. And maybe some explanation about the minor. I said that it's determinant, but I think it would be better if we say that this is determinant for this 1, 2, okay? For this row 1 and column 2, okay? Because the whole determinant we need to calculate all, right? Okay, so cofactor and minor, and then based on all this calculation here, we can calculate all determinants, okay? All determinants. Let me write in the next slide. determinant of a square matrix. Okay, if A is n by n matrix, then determinant A let's say this is A11, A12 until A1, let's say n. And this is started with A21 until AN1. This is A22 and then A2N. This is AN2, this is A, N, and N. Okay. Okay. Now we can say that the determinant will be A11 multiplied with the cofactor 1, 1. Okay. And then plus A12 multiplied by A12 plus plus A1N multiply with A1N. Or, okay, or we can also start with A21, A21 plus A22, A22 plus A2N, and then A2N, the big A. So this result will be the same as this result. And if you think like you want to start with the first row and the second row and then until the last row, and you try to find each determinant, it will be resulting the same value. Okay. So whenever you start, like any row you select, it will be resulting the same value. So it will be some suggestions. Okay? If you see like a numbers, you can imagine like which way you think easier to count. First row, second row, or the third row. And after that, you can delete the column, the first column, delete the second column, delete the third column, and calculating each one by one. Okay? And you get at least three. If you have 3 by 3, you have the element and the cofactor, element, the cofactor, element, the cofactor. If you have 3 by 3 matrix, at least 3 by 3 is, I think, in this course will be the maximum for the number of row and column that you need to be able to solve. Okay, and then okay, for example, if A is matrix 3, 2. And also, I forgot one thing. You, this is expanding the row. Okay, you can select the row, or you can select the column. That's also possible. But I think it will be the same. Like for example, if you select this, then you need to delete this for the first value, and then delete this for the second value, delete this for the third value. If you select this column, then you have first delete this, and then delete this, and then delete this, right? So I believe row and column, you can select like which row or column you want. Okay. Let me show you example. So you can, so if this is the matrix, okay, you can select this, or let me, okay, you can select this, this, and this, and then this will be the value for determinant AD BC. Okay, so you can select like the row or select the column. The result should be the same. But if you're confusing which way you are going to do, just make it the first row, much easier. But if you want to like, maybe want to try another way, or maybe you see the number and then maybe there's some difficult number to count, then you can adjust your method. Okay. Okay. Let's see this example first. Okay. This is the matrix A. Let's try just the first row. Okay. Just the first row. So let me write in red. This is the first row we try. And then the other one. Okay, now what we did, or what we are doing here is, first we are deleting the first row, right? So to get the tree value, so first row and then first column. Okay. So we have 2 multiplied by 6 minus 5 multiplied by 4. Okay. 12 minus 20. It's negative 8. Or let me write down all the process first. Okay. So this is 2, 4, 5, 6. Okay. And remember, this will be positive, negative, positive. Okay. So this is positive 2. And the second one will be the 3, right? But it will be negative. Okay. Negative 3. And how we get the number? So 3 is here, right? So, and then cover here, cover this. So we have 0, 6, and 4, negative 2. Okay. So positive, negative, and then positive. Okay. But this is negative 1. So just it's negative. Okay. So negative 1. So negative 1. Or maybe to make it more clear, let me plus and then negative 1. Okay. And then this is will be 0, 2, negative 2, 5. So this 12 minus 20, negative 8, 2, negative 16, 0 minus 8 plus 8, but negative 3, negative 24. Okay, let me write down the answer. So this will be negative 16, negative 24, and then 0 minus 4, and then minus 1, it's minus 4. 0 minus minus, okay, and then minus, so minus. So it will be minus 44. Okay, let's try the second row. So 2, 3, -1, 0, 2, 4. Okay. Now it is much easier. The second row, it has 0, right? So the first one will be multiplied by 0, and we just have 2 value. Okay. So let's start to count. So this will be 0. Let me write all the possible. So this obvious. This is we covered this one, the second row. We covered this and this, right? And here. Okay. So you have 3, -1, 5, 6. Okay. And then plus 2. It will be 2, 2, -1, and 2, -1, and -2, 6. Okay. This actually negative plus negative. So this is actually negative. Or let me write the negative so it's much more clearer. It's -0, but it's 0 anyway. And then -4, 2, 3, -2, 5. Okay, it's easy, right? 0. And the second one is 12 minus 2, right? It's 10. So plus 20. And then the last part, 2 by 5 is 10 minus 6. So it's 16. 16 by 4 is what? -64. So it's -44. So same results, right? Same results. Okay. You can try the third row. You can also try the first column, the second column, the third column. The common mistake you will make is the signs. So I was just giving you tips to solve this. Okay. Please be careful on these signs. Okay. If you are confused on the signs, my suggestions, you can make these signs. Okay. You can make these signs: positive, negative, positive, negative, positive, negative, positive, negative, positive. Okay. So whenever you are choosing your row and column, you always know that, okay, if I'm choosing here, then this is will be multiplied by +1. If I'm choosing here, I'm multiplying with the negative and this positive. Or here, it's negative, like this one. It's negative, positive, negative. Usually, we remember the first row, and then when we choose the other row, we choose the same value for the sign, and then the answer will be incorrect. Okay. So that's the determinant on the n by n matrix. Okay. Okay. Let me make some additional notes. Okay. It's called the invertibility. Invertibility. So if A is square matrix, then A has an inverse if and only if determinant A is not equal 0. Okay. So when your determinant, the value getting 0, then it will not have inverse. Yeah. So inverse will be if your determinant is not equal 0. Okay. I think I will continue the rest tomorrow. Okay. We still have some for the matrix, and I think I also want to giving you the partial fractions because it's also in the chapter, the same chapter as the matrix and system of inequality. Okay. Okay. Now, any questions? Okay. Or any questions regarding your quiz? Last quiz? Yeah. And our schedule for final exam, our schedule, uh, we we are start from 11, 12, 13, right? In January. So this will be January. This is Monday, Tuesday, Wednesday, Thursday, and Friday. Um, Probably I will set the Wednesday. Is that okay? Because our course 2 hours is on Wednesday, right? So probably January 13 will be the basic math. Um, but okay, if we can finish um like we can finish really fast, we can also have in the 6 if you want. But to be safe, make it 13. Okay, make it 13. Yeah, next week. It, I'm not sure. I think maybe here maybe but it's 19, 19 or 20. Okay, but to be safe, let's mark this as the goal, our goal first. Okay, our goal. I think that's it for today. We'll continue